So hello everyone, good evening. Just start joining this class and share this link with all your friends like who are preparing for this ICAR PG exam 2026 in the subject of soil science. So today we are kickstarting our most expected series, most expected questions for the ICAR PG exam in the subject of soil science. तो आज हम soil science का questions discuss करने वाले हैं. So and I will not be teaching the soil science. Our mentor is waiting to engage the class. But before that, let me like formally introduce her, and also like this is the very first class of this revision series for 2026. So I have few things to convey you all. So just quickly share this link with all your friends. So all your juniors, seniors who are giving this exam of 2026, maybe like students who are giving the exams of 2027, still they are interested to join this class. Everyone are welcome. So these are the free YouTube classes for all of you who are sincerely preparing for this exam. Okay. So good evening everyone. Please let's confirm me once in the chat box like if I'm audible to you all. If my voice is clear, just say yes, you're audible, or just say yes if I'm audible. Everyone, I'm audible to you all. Confirm me once in the chat box. Yes, Purti, good evening. Thank you if I'm audible. Like the video is clear. Video clear है सबके लिए? Yes, yes, yes. Start joining. Like let's start this class today. आज revision series properly start करते हैं. So good evening everyone. So now you all know like we have successfully completed our 2026 ICAR PG 2026 course for the soil science. Soil science का जो 2026 कोर्स है हमने बहुत अच्छे से इसको कवर किया है. हमारे मेंटर्स ने हर एक कैटेगरी को बहुत अच्छे से एक्सप्लेन किया हुआ है. लाइव क्लास दिया है, रिकॉर्डेड क्लास अवेलेबल है, नोट्स प्रॉपर्ली अपलोडेड है एंड दे आर नाउ वर्किंग ऑन द हैंडबुक टू. प्लस आपको डेडिकेटेडली टॉपिक वाइज सब्जेक्ट वाइज होल सिलेबस का मॉक टेस्ट दे रहे हैं एंड रेगुलरली द मॉक बुक सीरीज इज गोइंग ऑन in our master course and the mock test bundle, plus also the general agriculture mock tests are going on or the quiz is going on your telegram channel. I hope all of you are taking all of these benefits. आप लोग इसका benefit ले रहे हो और अच्छे से इस एग्जाम को प्रिपेयर कर रहे हो. And today since like the entire syllabus is completed, the what's the next point? The next thing was the revision series. As I've already committed that हम लेकर आएंगे रिवीजन सीरीज आपके लिए बिफोर द एग्जाम. तो एग्जाम से पहले हर दिन कुछ ना कुछ रहेगा, हर 2 दिन में एक वीडियो आएगा ताकि आप मोटिवेटेड रहो, आप कंसिस्टेंट रहो और आप हर रोज कुछ ना कुछ नया सीखो और उसको रिवाइज करते रहो. So today like we are starting the revision series for the ICAR PG, so soil science का revision series कर रहे हैं and this is divided into 2 different parts. The one part is discussing the most expected question for this ICAR PG exams and the second part is like marathon. So the most expected series like we'll be completing anywhere within the May this month and the next month in the month of June, like when the peak month of the exam preparation, yes, we will be conducting the marathon series. This marathon series will be divided into subject wise. Even within the soil science subject, we'll be categorizing it into different things like soil physics, agriculture chemistry and soil pedology. So different sections will be dealt differently in 1.5 to 2 hours in a long single session where whatever you have learnt till now, whatever you have read till now, everything will be at a glance. Okay, so that will definitely help you. And from our end, through this most expected series and the revisions marathon series, there will be like 2 times of revision that you can do with us. And today we are continuing or we are starting with the most expected series. I hope you all are excited for this and you are all are waiting for this sessions to begin. And Purbita, like our mentor is with us, like she's come up with all the energy right now. So she will be giving the most expected series. She will be discussing about all the questions in this, and this is the paper of ICAR PG Soil Science 1, which is already been uploaded in the mock test bundle. So if you have already attended that questions, so you will be able to easily answer the questions, plus wherever you get the doubts, you will be able to clarify it. Purbita, please welcome. So welcome. It was a long break for you and you had some holidays. Fine. So thanks for being back and continuing this series. I hope like this series will definitely benefit all the students. So students like who are watching this video, अगर इस वीडियो से आपको कुछ भी वैल्यू मिले, तो डोंट फॉरगेट टू लाइक, शेयर एंड सब्सक्राइब एंड आल्सो कमेंट ऑन दिस वीडियो like what was your feedback about the videos and tell us whether we have to continue this series, whether you want the marathon series from the AgriAddict or not. So wish you all the very best.
Thank you, sir. Thank you for this introduction. So, hey guys, I am Purbita as already.
Now am I audible? Now am I audible? Okay. So let's begin. Study of soil from the standpoint of higher plants is known as, quickly answer. See, what do we know about pedology? Pedology, it is the study of soil science as a whole. Okay. Hydrology, it is the study of water science. Edaphology, that we will keep it. Soil fertility, you know that it is the inherent capacity of a soil to provide essential nutrients for the growth and development of the plants. Now, can you tell me this logy word? It comes from which word? It comes from logos. And this logos is in fact a Greek word. Okay, so wherever you will see logy, it comes from a Greek word. Pedo or the pedon, it means soil or land. So this is the study of soil. Again, this is the study of hydro, means water. And when we study the soil from a standpoint of higher plants, it is called edaphology. Okay, it comes from two words, edaphos and logos. Clear? Yes, it is C. So this is the explanation given over here, that pedology is the study of genesis, survey, classification and geological distribution of the soil. All these things are together covered in pedology, and edaphology is from the standpoint of higher plants. Okay. Next, who said that soil is more or less a loose and friable material in which plants by means of their roots find a foothold for nourishment as well as for other conditions of the growth. So these, the names of the scientists along with what definition they gave, you have to remember it. So what will be the answer? See, Raffin is there, Hilgard. Then there is Dokuchev. So we know that Dokuchev, he is called as the father of modern pedology or father of soil science, right? And he was a Russian scientist who first gave this concept of soil science. And according to Dokuchev, the soil is actually a natural body, right? Then there is Jenny, and he said the soil is a naturally occurring body. Dokuchev said that it is a natural body. Jenny said that it is a naturally occurring body. And then there is Hilgard, who said that soil is a loose and friable material. So you have to remember the keywords and which scientists gave the keywords. No, the answer is not D, the answer is B, that is Hilgard. And what did Raffin say? What did Raffin say? Raffin said that soil is just a material that is lying on the surface of the earth. Okay, material that is lying on the surface of the earth. So, it is a mixture of this earth's uppermost mantle of weathered rock and organic material. This is given by Raffin. Then Hilgard gave that, and V.V. Dokuchev is the father of modern pedology. Can you tell me who is the father of American pedology? Who is the father of American pedology? Answer in the chat box, please, guys. Who is the father of American pedology? So he is nothing but Marbut. Okay, Marbut is he's the father of American pedology. So after Dokuchev gave his Russian pedological concept, there was Marbut who was American, and he founded that instead of genetic system of classification, we have to move on to morphological system of classification. Next, lithophiles are. So you know that different elements on the earth's surface, they are divided into different categories. One is lithophiles, then we have siderophiles, then we have chalcophiles, we also have atmophiles, right? So what are lithophiles? Lithophiles, okay, they form stable oxyanions. That is the answer coming in the chat box, I guess. So let's see. Yes. So lithophiles will ionize readily and form stable oxyanions. Chalcophiles, always remember. What are chalcogens, guys? What are chalcogens? Chalcogens are group 16 elements like that of oxygen and sulfur. But we do not consider oxygen here because already lithophiles are forming stable oxyanions. So we will consider the elements that tend to form covalent bonds with sulfide, S2 minus. Then we again have siderophiles. So siderophiles are the ones which readily form metallic bonds. Can you give an example of siderophiles? For example, iron. Okay. Boron is also there. So all of these, they will readily form metallic bonds. Then, yes, iron, very good. And another thing with in relation to siderophiles is phytosiderophores. So can anybody tell me what are phytosiderophores? These are some elements that are secreted by biological organisms that bound with the iron. Okay. They bond with the iron present in the soil to make it easily available to the plants and to prevent its insolubility or prevent the losses of iron. So, from this term only, siderophiles came the term phytosiderophores. They have a high affinity towards iron, and phyton means plant. And atmophiles are which tend to remain in atmospheric gases. So, obviously, they will have a very low melting and boiling points will be there. Low melting and boiling points will be there, and they are highly volatile because they are present in atmospheric gases. For example, oxygen, nitrogen, hydrogen, all of them are atmophiles. Okay, yes, microorganisms bound with iron. Next, what is the decreasing order of average composition of the Earth's crust? So, this you should remember it like a mnemonics, that is OC, Alphi, Ka, Na, Ka, Mg, right? Right? So, OC, Alphi, Ka, Na, Ka, where is Alphi? So, what will be the answer, guys? Okay, somebody saying A, somebody saying B. So, let's see. So, it is B. See, the percentage of oxygen, it is 46.6%. Very, very important. Then comes silicon. That is 27.72%. So, from here also questions can come like, which is the most abundant element? Which is the most abundant element on the Earth's crust? Which is the most abundant non-metal? Which is the most abundant metal? And which is the most abundant cation or basic cation or exchangeable cation, whatever? Okay. So, if they say that what is the most abundant element, then obviously oxygen, because oxygen is an element. It is neither a metal, okay, it is the most abundant element overall. If they ask you what is the most abundant non-metal, then you can also write oxygen over here. If they ask you what is the most abundant metal, then you will have to answer this. And then what is the most abundant cation or basic cation or exchangeable cation? That is calcium. So, see all of these three, that is silicon, aluminium and iron, all of these are cations, but they are not basic, neither are they most exchangeable. So you cannot answer that. So you have to write that the most abundant basic cation is calcium. But one PYQ came and there they had given the answer of Al3 plus, but that is not right. Okay, calcium must be the most dominant basic cation. Now, what are minerals? So, are they naturally occurring? Are they homogeneous? Are they organic? Do they have any definite chemical composition? So, they will be naturally occurring, they will be homogeneous, they will have a definite chemical composition. That means they will have a fixed boiling and melting point, they will have a fixed molecular formula and all that, but they will not be organic. They are strictly inorganic. So, the answer is A, B and D. Okay, A, B and D. Good. So, can you tell me that when several minerals, they will occur together, what is it called? Several minerals occurring together is called as an ore of that particular element. So, from that ore of that particular element, suppose we have an ore of iron and from there we can extract the iron mineral. And can anybody tell me what is the difference in between the rocks and minerals? This is also a very important concept of pedology. So, rocks are made up of one or more than one minerals. Okay. Yeah, smelting is done, but through smelting process you can say that we can extract a particular metal from the ore. But what is the difference between rocks and minerals? So, rocks, they are composed of several minerals, fine. But what is the difference between rocks and ores? So, for ore, there must be a particular abundance of a particular element. But for rocks, they can be in a combination of different elements together. But the ores, they must have one element in abundant composition so that you can extract that element from that particular ore. Okay. So, see, these are naturally occurring, homogeneous or inorganic, mostly crystalline compounds. And also, can you tell me that if I divide the minerals according to crystallinity, then I will have what different kinds of minerals? I will have crystalline minerals, I will have paracrystalline minerals, and I will have amorphous minerals, right? Amorphous as well. So, some amorphous minerals are also there. So, give me 2 examples of amorphous clay minerals. 2 examples of amorphous clay minerals. Quickly on the chat box. So, what are 2 examples of amorphous clay minerals, guys? Quick. So, it is allophane and imogolite, right? Allophane, imogolite. These are amorphous in nature. Okay. For the paracrystalline minerals, they will not have a long range order in 3 dimension. No. Long range order in 3 dimension, they will not have. If they have long range order in 3 dimension, then they are crystalline. But if they have, suppose short range order is there, that means up to a particular point they are crystalline in nature, then we can classify them as paracrystalline. Okay. So, crystalline minerals, you will find that most of the silicate clay minerals are crystalline, and yes. Okay. Now, let us move to the next question. Which of the following statements is incorrect? See, petrogenesis, origin of rocks. So, genesis means origin and petro means rocks. So, origin of rocks, fine. Petrography. So, wherever there is graphy, that means description, fine. Up to 5 kilometers of the earth's crust, sedimentary rocks predominate. This is also an important statement, that is, the percentage of sedimentary rocks in the upper 5 kilometer of the earth's crust is 74%, whereas that of igneous rocks is only 18%. But for the rest 95 kilometers of the earth's crust, the dominance of igneous rocks is 95%, whereas the sedimentary rocks is only 5%. So, it is true as well. Up to 5 kilometers of the earth's crust, sandstone exists as 52%. So, what kind of rock is sandstone? What kind of rock is sandstone? And up to 5 kilometer, it exists as 52%, whether or not it is. So, it is a sedimentary rock obviously, and the sedimentary rocks dominate the upper 5 kilometer of the Earth's crust. So, this is supposed to be true. So, you see that petrology is the branch of science which deals with the study of the rocks, but instead of sandstones, the shales are the ones that are dominating the Earth's crust, not the sandstone, it is only 15%. Whereas limestone and dolomite, it is only 7% and others it is 8%. So, instead of sandstone, here it should be shales, okay. Shales must be there. So, the answer is option number A, B and let us see only D, okay, only D. So, let us see, petrology is the branch of science that deals with the study of, okay. So, here it is origin of rocks, here it is description of rocks. But I guess the answer will be A, B and C, because here it is genesis, that is origin, and if it is logy, that means it is study. Petrography is the description. So, the answer is, so the option is not present, it should be A, B and C altogether, okay, not the D. Okay. Now, let us see which type of rock dominates the Earth's crust as a whole. So, we had learned that the upper 5 kilometer of the Earth's crust, in the upper 5 kilometer what is dominant? Sedimentary. But in the rest 95 kilometers of the Earth's crust, what is dominant? Igneous rocks. So, as a whole, which kind of rock will be dominant? Obviously, igneous rocks will be dominant, right? So, it is igneous. So, it is saying that although the sedimentary rocks form only 5% of the total Earth's crust, they are important. So, they will form only 5% of the total crust, okay. Now, coming to the next statement. So, this weathering, transportation, deposition and diagenesis, these are the stages that are associated with the formation of which kind of rock? So, obviously, igneous rocks, that means what? They are formed from igneous. Igneous means fire. So, that means they will be formed from either the magma or the lava, okay. The sedimentary rocks are formed through all these different processes of weathering, transportation, deposition of different sediments, okay. And the metamorphic rocks are formed as a result of alteration of both the igneous and the sedimentary rocks, okay. So, there is option number B, they are saying yes, it is good, fine. Then igneous and metamorphic, it won't be there. So, the answer is B, which is sedimentary rock. So, here is a description of all the processes. Weathering is the breakdown. So, if it is physical weathering, then there will be only disintegration. If it is chemical weathering, then there will be both disintegration plus decomposition. Students often make this mistake. You are given a statement where physical weathering means both disintegration and decomposition. So, you will just see it and tick the correct option. But physical weathering will only involve disintegration and no decomposition. And biological weathering, it is a, you can say, secondary process where the biological organisms, they either through decomposition or through disintegration, they form this different sediments. Then transportation is, after the sediments are formed from weathering, they will be transported by different agencies. So, what are the agencies? It can either be gravity, it can be the rivers. So, if it is gravity, then it is colluvium. If it is rivers, then it is alluvium. If it is lakes, then it is lacustrine, okay. If it is glaciers, then it is either tills or moraines. So, like this, different weathering agents or transportation agents will give you different names of the sediments. Then finally, these materials will be deposited and the coarser particles will settle down first because of their larger size. And then diagenesis means when these sediments, the sediments are loose and friable, so they will be together compacted and consolidated together. So, this diagenesis will involve two processes. One is compaction, cementation as well as lithification. What is lithification? It is the consolidation of unconsolidated sediments. That means when the loose and friable sediments, they will together stick to one another and form a consolidated mass. So, all this is involved with sedimentary rocks. Then what type of rocks are gabbro, pumice, dacite and granite? So, everybody knows it is igneous rocks. So, pumice, among that, it is the most lightweight rock, you can say. So, granite, it is an intrusive igneous rock. Gabbro is also there along with basalt, and then dacite is there. So, let us see. See, basalt is the most abundant extrusive rock. Okay. Gabbro has the similar properties of basalt, but it is coarse grained. Rhyolite is similar to granite, but it is fine grained. So, if I divide it as intrusive and if I divide it as extrusive, then within extrusive we will have basalt and rhyolite, and within intrusive we will have granite and gabbro. So, this gabbro, it is similar to basalt, and this rhyolite, it is similar to granite, but only the texture will differ. Then pumice is very lightweight and it will float on water. So, all these are examples of igneous rocks. Similarly, you have to remember the examples of sedimentary as well as metamorphic rocks. So, can anybody tell me the example of sedimentary rocks? Just a few questions back, we will have shales, we will have sandstone, we will have conglomerate, right? Limestone, dolomite, all that. In the metamorphic rocks, we will have marble, right? We will have quartzite, all that. We will have slate. So, you have to remember the examples. Now, which of the following is or are the examples of nesosilicates? Yes, limestone is also there. Okay. So, can anybody tell me nesosilicates, what is the formula? Basic structural formula of nesosilicates? It is SiO4 4-. So, these nesosilicates, they are the ones that do not have any oxygen sharing with the neighboring silicate atoms. So, these are the most easily weatherable silicates, and obviously olivine will be there. Ferrite is nothing but it is a particular kind of olivine. See, ferrite is also a particular kind of olivine, right? Because we will have forsterite and ferrite. Olivine is a series of minerals, and within that forsterite will consist of magnesium olivine Mg2SiO4 4-, and ferrite is iron. Okay. So, ferrite is also there within the olivine series, and silmanite, what do you think about that, guys? Biotite is again black mica. So, biotite is not a nesosilicate. Biotite is not an nesosilicate. So, let us see. So, all of the three, that is olivine, you see ferrite, forsterite as well as the silmanite, that will also fall within the olivine series, because I said that olivine is a group of minerals, okay. But instead of biotite, all the rest three will fall under the olivine series. So, the answer is A, B and D only. Now, given below are the two statements. In case of sorosilicates, one oxygen sharing occurs. So, that is true, because sorosilicates formula is Si2O7, right? This one is the structural unit. So, one oxygen sharing will happen. Orthosilicates, iono, phyllo are called ferromagnesian minerals. Phyllosilicates, they are not ferromagnesian, okay. So, in the light of above statements, choose the most appropriate answer. So, nesosilicates are also called as orthosilicates. Then we have neso, soro, cyclo, iono, phyllo, tecto. This is the silicate order, right? So, those silicates that lie in the above classes, they will fall under ferromagnesian minerals, and they will be somewhat up to the ionosilicates, but to an extent, okay. Then from the phyllosilicates and the tectosilicates, they will be non-ferromagnesian. That means they will not have major abundance of iron and magnesium. So sorosilicates, yes, one oxygen sharing occurs. Orthosilicates, inosilicates, phyllosilicates, C. Only biotite and not muscovite. So as I said, because here there is given that phyllosilicates are called ferromagnesian, but within phyllosilicates only one group, that is biotite, which is black mica, will fall under the ferromagnesian element, but not the white mica or the muscovite. Okay. So that is why they had considered this to be true, because biotite is a part of phyllosilicate. Coming to the next question. So these are our courses, and for those who are watching our video, all of this has been covered in our master course that is specially curated for the ICAR JRF, and it is also running at a special offer because JRF is knocking at the door. So you can all avail our courses, okay, and boost your preparation. Now, heavy minerals have a specific gravity of. So, what will be the answer? Heavy minerals have a specific gravity of. Quickly answer, and also you will have to tell me the unit. What will be the unit? Okay, option number C, very good. So, it is greater than 2.85. So, if I had only asked about the density, then the unit would have been gram per centimeter cube, right? But here they had asked specific gravity. So, specific gravity means what? Density of a particular mineral to that of hydrogen. So, the density units get cancelled out, and that is why specific gravity is a unitless quantity, and it is greater than 2.85. So, above that we call it as all heavy minerals, and below that we call it as light minerals. Now, can anybody tell me that what is the like approximate or average particle density of our soil? Average particle density of our soil. Quickly. Yes, it is 2.65 gram per centimeter cube. Now, why is it 2.65 gram per centimeter cube? Because there is another element called quartz. And this quartz fraction, it is the most dominant fraction that is present in our soil, and that has a density which is close to 2.85 or 2.65, whatever. So, that's why the particle density of our soil assumes a value of 2.65 due to the abundance of quartz. So, here it is all given. The examples of light minerals as well as heavy minerals are also given. So, you can see over here and answer from here. Okay. Now, resistance of minerals to scratching is known as dash, and it is expressed in dash. So, if anybody knows the answer. So, what are striations? Let's see. Okay. So, if suppose this is your mineral and there are alternate light and dark patches that are present in your mineral due to several pedogenic processes, then it will be striation. Yes, option number D is the correct answer, Spurti. Now, what is talc scale? Talc scale is a scale that is used to measure the hardness of any mineral, but with respect to talc only. And you cannot measure the hardness of different minerals. This is not a principal scale for measuring the hardness. Then what is tenacity? Tenacity, it is the, let's see the definitions over here. So, it is the resistance of that of a mineral offers to breaking, crushing or binding. So, it is the tenacity with which it can hold its structure against a deformation force that is externally applied. Okay. Striations are the parallel thread-like lines. Hardness, on the other hand, is the resistance of a mineral to scratching, and we have Mohs scale of hardness where talc is the softest and diamond is the hardest mineral known. So, it has several numerals from 1 to 10. Also, you have to memorize those numerals. And cleavage is nothing but it is the breaking of a mineral along the lines that are vulnerable to breakage. Okay. Lines that are vulnerable to breakage. Okay. Now, arrange the following in increasing order of Mohs scale of hardness. Obviously, talc will be the least hard mineral. So, first A will be there, but in all these options A is there. Okay. Then we will have gypsum. Gypsum is CaSO4 dot 2H2O. Then we will have quartz, which is a tectosilicate, and we will have fluorite, which is a secondary mineral of fluorine. So let me show you first, okay, what will be the answer? So somebody is saying A, B, C, D, Purti is saying A, B, C, D. So let's see Moho scale of hardness first. Talc, gypsum, calcite, fluorite, apatite. Then we have feldspar and finally we have quartz. So first is talc, gypsum, then calcite is not there, fluorite is there, apatite is not there, then feldspar is also not there. So quartz, so A, B, C, D is the correct option. Good. Now, when water turns into ice, its density will see. Have you heard about this anomalous expansion of water? Where if I have temperature in this hand and density or volume in this hand, then you must know that at 4 degrees centigrade temperature, the density of water is maximum and thereby it declines. But at that particular 4 degrees centigrade temperature, because density is inversely proportional to volume, the volume will be least, right? So let's see. So when water turns into ice, the volume increases, but the density decreases by 9%. Okay, volume increases, but here they are asking density, so it will decrease by 9%. And that is why freezing water is a very good weathering agent, because when the water freezes into ice due to an increase in the volume, it will highlight the cracks that are present in the rocks. Okay. So, cold temperature causes freezing, and this value you have to remember 1465 tons per meter square, resulting in the breakdown of the rocks. This is also very important, and another one is 150, that is foot per pound on that scale. Okay. So, these two values you have to remember, that what is the force exerted. Now, which of the following chemical weathering process is most important for primary minerals? Tell me. Most important for primary minerals. Okay, so let's see what is hydration. Hydration is whenever there is a mineral and just one molecule of water will come and add up. So the mineral, yes, okay, they are answering B, hydrolysis. Okay, I will keep it for some time. So hydration is whenever a mineral is there and water molecules, they are present, but they are not chemically breaking down a particular mineral. The mineral is just absorbing the water molecules, it will have a slaking action, then it will weaken up and then it will split apart. But in case of hydrolysis, this water, it will break down into H plus and OH minus ions, and then it will, this H plus, this is very reactive, and then it will go and react with that particular mineral and cause its breakdown. Carbonation, it is due to carbon dioxide or carbonic acid, that is H2CO3, the breakdown, and oxidation, you know that it is the loss of electrons or addition of oxygen. So, hydrolysis is actually the most important process for primary minerals, and what is the other name of hydrolysis? We can also call it as the forerunner of clay formation. Forerunner of clay formation. But can anybody tell me what is the most important process of chemical weathering for primary minerals? So, when the term is primary minerals, when the term is secondary minerals, what will be the most important process? So, if the minerals are secondary, what will be the most important process? Yeah, double decomposition, you can also call it as double decomposition. So, if these are secondary minerals, yes, then hydration will be the most important process. Okay, good. So, here it is given the description of all the different processes, most important chemical weathering, and you have to memorize each and every point because it is very important, all the processes of chemical weathering. Now, what type of weathering is exfoliation? So, what does exfoliation means? If you have a rock, then the outer layers of the rocks, they will peel like onion skin, and that is called exfoliation. So, what kind of weathering is exfoliation? Okay, they are saying A, let's see. Yes. So, it is due to physical weathering. Why does exfoliation happen? Exfoliation happens due to differential expansion and contraction of minerals. So, that differential expansion and contraction can happen either due to a change in color or chemical composition of that particular mineral. So, there might be different factors because a mineral is not made up of a single kind of element or a type or exhibit a single color. So, that can cause differential heating and cooling, and that can lead to exfoliation of the cracks, and mostly it is found in igneous rocks. For example, granite and basalt, exfoliation process is most common. Now, which of the following statements are not correct about hydrolysis? It is a type of physical weathering. Is hydrolysis a physical weathering? Obviously not. It is a type of chemical weathering. Yes, it is a type of chemical weathering. It is also very important on primary minerals. But for the secondary minerals, we had already stated that hydration is an important process. So, option B and C are correct, and it is a chemical combination of water molecules. So, option B and C are correct, and I think you can also add this one option because this E is somehow not over here. So, B, C and E, all the three statements are correct. Why is it a chemical combination? Because water, it is breaking down into H plus and OH minus ions. Okay? And that is why it is a chemical combination. But in case of hydration, it will be a physical combination. It will be a physical combination. Clear? So, here is the explanation. Why is hydrolysis important and the different factors regarding hydrolysis. Which of the following weathering stages, the less resistant minerals are decomposed easily and the clay content increases. So, these weathering stages, who gave the weathering stages? Okay. Who gave the weathering stages? So, they were given by and Van Webb. Right? So, the weathering stages of different elements were given by Moore and Van Garen, and they are divided into initial, juvenile, virile, senile and final, right? So, out of that, in which of the following Clay Suspurti is saying B? Yes, virile is the answer. Virile is the answer. So, according to initial stage, what will happen? None of the materials have decomposed. Okay. All the materials will be present. In the juvenile, only the most easily weatherable minerals will decompose. In case of a virile, there will be a gradual increase in the clay content. In case of senile, only the most resistant minerals will predominate, and in the final, the weathering process is complete. Okay. Now, removal of clay, particularly of fine clay in suspension from the upper part of the soil profile and its accumulation in the lower part is called. So, they are stating that the clay removal, okay, in suspension from upper part of the soil profile and its accumulation in the lower part. So, this is a very important term which is called lessivage. Okay, lessivage. Now, what is leaching? Leaching is just, yes, C is the answer. Now, what is leaching? Leaching is just the escape of water along with different nutrients and salts from the root zone. Rigor is nothing but it is a black soil, and ferruginization, it is the process of breakdown of iron from the primary minerals. That is also called as brownification. and lessivage is also called as clay migration. So, this term lessivage was also given by Dachafor. Okay. Brownification is also called rubification. So, you have to know about all these different terms, and sometimes people confuse it with emigration because clay is moving from the top layer to the bottom, but it is not that. Whenever you will find the word clay, always remember that it must be lessivage only. Now, sediment transported and deposited by air. So, what is it called? Please answer, guys. So, for alluvium, we know that it is by river, right? River water. Marine, we know that it is by aquatic water, sea water, till glacial movement. Yes, B is the answer. So, aeolian, and aeolian will be when what will be dominant, sand or silt? When sand will be dominant, and if silt is dominant, then it is called loess. Okay. So, these are the different weathering agents along with their sediments that are transported. Here we have given a brief description of the different weathering elements and what are the names of the sediments that are deposited due to them. Please go through it. Okay. Coming to the next question, stability series was proposed by. So, with this another question comes that weathering index was proposed by. So, stability series was proposed by, yes, Rakshita, you are saying A. Okay, Spurthi is also saying A, but I do not think that A will be the correct answer. Why? Stability series was proposed by Golditch in 1938 and weathering index was proposed by Jackson in 1964. So, stability series given by Golditch, weathering index by Jackson. Okay, do not confuse all this. Golditch's stability series, olivines will come. Okay, then pyroxene, then amphiboles, then biotite will come, right? And here we will have the feldspar series. Right? This will be all the Na feldspars, and then we will finally, after this biotite, we will have the K feldspar, that is the plagioclase. Okay, plagioclases will be there, orthoclases will be there, and finally muscovite and the quartz. So, this is the entire stability series that was proposed by Golditch. Voice not clear. So, is the problem for everybody? Is the voice problem for everybody? Now, am I audible properly? Okay, okay. So, Gokul and Satya, Anu, am I audible? Okay, okay, fine. So, this is the entire stability series, and for the Jackson's weathering series or weathering index, every mineral is associated with a particular number. So, that also you have to remember. Now, sediments deposited by streams of flowing water when they enter plains from the hilly areas are called. So, whenever they are entering plains from the hilly areas, they will tend to spread their sediments, right? So, let us see. So, they will lead to the development of alluvial fans because they are entering plains from hilly areas. So, they will spread their sediments in the form of fan shaped motion. Okay. And let us see what are alluvial terraces. So, alluvial terraces will be found in hilly areas only. In hilly areas, the water that will be, the sediments that will be deposited in the hilly areas will form the alluvial terraces. Delta deposit means when the river meets the sea, and floodplains will be formed in those areas where there are problems of intermittent flooding, okay, according to the season. Now, who stated that flow of water through a narrow tube is directly proportional to the fourth power of radius r to the power 4, the pressure difference, and inversely proportional to the viscosity and length of the tube. So, this is nothing but Q is equal to pi r to the power 4 by 8 eta L. So, this is whose equation? It's Poiseuille's equation, and this is for a viscous fluid because here we are considering the coefficient of viscosity. Darcy's law is nothing but the flow of water, that is Q by AT. This is the flux. We call it a small q. It will be directly proportional to the hydraulic gradient, del H by L. Okay. Then Bernoulli's theorem, it will state the conservation of kinetic energy, then pressure, all that together. So, Bernoulli's theorem will deal with the conservation, and Pascal's law, it is nothing but pressure. Okay, Pascal's law is nothing but pressure. We express it as Newton per meter square or force per unit area. So, this is Poiseuille's law, and Q, it is the amount of water that is flowing through a narrow tube. Okay, good. Now, so this is Poiseuille's law. Coming to the next question, which epipedon is characterized by a thick, dark colored, soft mineral horizon with high base saturation? So, find the keywords. Whenever we have the high base saturation, that is greater than 50%, containing 1% of or more organic matter, and with soil structure that cannot be massive or hard. So, it is obviously when the base saturation is greater than 50%, it has to be maulic horizon. So, what is ochric horizon? Ochric horizon, it is a horizon with low chroma. Melanic horizon is where generally andic materials or andic properties are there, volcanic ash kind of properties are there, and histic material means it has a great deposition of histose or tissue, and this horizon, it has to be deeper, like these are all. Okay, so in case of histic material, the material must be at least wet for 30 consecutive days, right? So, all these horizons as well as the different kinds of pedons you have to remember. So, let us see maulic epipedon greater than 50% base saturation, okay, and containing 1% or more organic matter, and very important thing is that it cannot be massive and hard. That means because of 1% or more organic matter content, it cannot be massive or hard. Now, which of the following suborders belong to altisols? So, whenever we name a suborder, we always have several prefixes or suffixes, and here for in case of altisols, it is alts. So, we will only have to find which of them have, okay, which of them have alts. So, obviously it is woodalts. For the wood alps, that means they will have alphisols. Woodox means oxysols. Ands means andisols. Okay. Eps means inseptisols. Entisols, like that. Okay. So, all the suffixes you will have to remember for a particular order. Yes, C is the correct answer. So, this is our course, and because JRF is knocking at the door, you can access our course at a discounted price right now, and where all of these topics are covered, and this particular mock test is available in that course. So, you can also go and check it out. So, these are all the names of the soil forming orders given, and what will be the prefixes, and also read this one. This is directly taken from the old ISSS, that is, what is the meaning of all these terms. Okay, some terms have meanings and some do not. Like this entisols, it has a nonsense syllable. Alphisols again has a nonsense syllable. So, they can also ask you the meanings of that particular syllables and you have to remember this. Now, according to USDA, the size of very fine sandy. So, we know that USDA has given the textural classes into different orders or different. So, you have first very coarse, medium, fine, very fine. These are all classes of sand. And then we have silt and then we have clay, right? So, tell me what will be the answer for this one? So, clay it is always less than 0.002 millimeter, and mind you, these are all the diameters that are given, not the radius, okay. These are all the diameters but not the radius. So, the very fine sand will be option number C. Yes, option number C. And also you have the IUSS or ISSS classification where they had divided into only 4 different groups. And for the USDA it is 7 different groups, and also we have another system, that is British Standard System of Classification. So, all these 3 classification systems you must remember, and these are all diameters but not the radius. So, the question can come like diameters or radius. So, for finding out the radius you will have to just divide all these values by 2. Okay. Now, what are the assumptions of Stokes' law is incorrect? Which of the following is incorrect? Particles must be spherical, smooth and rigid. Okay. Fall must be hindered. No, I don't think so. It should be unhindered. Particles must have a uniform density, obviously, and there is no slipping between the particles and the liquid. So, there must be no slipping. So, let us see what are the assumptions of Stokes' law. So, it is B. C. Why it is B? Only 2 is false. Why? Stokes has not considered anything to be of a uniform density. If they are of a uniform density, then how will you fractionate your particles based on density, right? So, they must not have uniform density, they must have variable densities. So, only 2 is false, okay. And because they had not assumed anything to be of density, we cannot consider this particular option in the question, because they have particularly asked for assumption of Stokes' law, right? So, we cannot consider this. So, first particles must be spherical, smooth and rigid. See, fall must be unhindered, and they must have a uniform density in the assumption section only. The uniform density of the particles, it should be like sand must have a uniform density, silt must have a uniform density, clay must have a uniform density, but the density of these 3, they should vary between one another so that you can fractionate based on density. मैम मेरा CUT PG एग्रीकल्चर साइंस में तो क्या मैं BHU में एडमिशन हो? Okay, you will have to like go. देखो आशीष, तुम्हें पहले एक चांस है, like in 212 it's a good marks, so you have to just go and fill up the counseling and then it's a good marks, so don't worry about that, okay. Now, soils that contain a high amount of organic matter typically exhibit. So, like if the amount of organic matter is high, then what will be the bulk density? It will be low bulk density, because organic matter will improve your structure, and low bulk density means less compaction, whereas a high bulk density means higher compaction, right? So, the answer will be option number B, because it will promote the soil aggregation. Yes, okay. Now, resistance of soil to deformation or rupture under applied pressure. So, what is the resistance of soil to deformation or rupture under applied pressure? What is plasticity? The property by which you can mold a soil and form a particular cylinder, right? So that it will not break down or rupture. Strength, it is the property of a soil, the resistance to deformation or rupture, and then again there is compaction. So, compaction means there will be a decrease in volume. and increase in bulk density, both. So what will be the answer? It will be, okay, so some are saying B, some are saying G. Now when I was taking your classes, I said particularly that this consistency and strength, these two have the similar kind of definition. But there is a small difference in the definition. In case of consistency, it is the resistance to deformation under applied pressure. But in case of soil strength, the definition here it is not under applied pressure. Okay. So, there is a small difference between the definitions of soil strength and consistency. So, you have to memorize the definitions, okay, of consistency and strength, and here the answer will be consistency, but not strength, okay. Now, when structure of two soils are compared, it will be better in that whose cumulative mean weight diameter is. So, always we look for soils whose cumulative mean weight diameter is higher or lower. Tell me. It should be lower. Okay. So, obviously, now what is this difference in between cumulative mean weight diameter? The change in mean weight diameter, it is dry and wet sieving conditions. So, if you have more difference, that means more number of particles will be dispersed in the wet condition than in the dry condition. So, that refers to poor soil aggregation, okay. And that is why we need a lower value. A lower value will signify that there will be the less dispersion of particles in wet sieving and a better soil structure. Now, the direct method of soil structure evaluation. So, there are two methods of soil structure evaluation. One is indirect and the other is direct. So, direct method is nothing but your microscopic method. So, you need a petrographic microscope, and all these are indirect methods of soil structure evaluation. Okay. So, option A is the correct answer. Now, arrange the following in descending order based on thermal conductivity. So, what is thermal conductivity? It is the property of a soil, or it is a property of any material, or the ease with which heat can pass through any material, that is thermal conductivity. And we know that sand, it has the highest thermal conductivity than loamy, than clay, than peat. So, this organic matter, so whenever there will be high specific heat of a particular material, if the specific heat is higher, then it will be inversely proportional to the thermal conductivity, because it will tend to retain more heat, okay. So, in case of sand, the thermal conductivity is maximum. Also, the thermal conductivity will depend on several factors, like what will be your particle-particle contact, what is your water content in your soil, okay. So, all these different factors will influence your thermal conductivity. Again, what are the kinds of minerals present, what is the soil structure, what is the soil texture, all these properties will influence your thermal conductivity. So, the quantity of heat that is transmitted through a unit substance per unit cross sectional area. So, this Q by AT is equal to K into del T, like this, okay. So, this K is nothing but the thermal conductivity, okay. Now, these are Fourier's law of heat transportation. Now, yes, option C, good. The process in which heat is transferred from one point to the other by the actual movement of heated particles. So, whenever the particles are moving, it is nothing but convection. Convection. Whenever there is no actual movement but only the vibration of particles in a particular place, then it is conduction. Radiation is without a material medium. Yes, the answer is convection. But what is the most dominant process of heat flow in our soil? It is conduction. So, it is dominant heat flow process in our soil, okay, that is conduction. Okay, next question. Which of the following crops is considered as an indicator of plant for determining the permanent wilting point of the soil? So, this is also an informative kind of question, and the answer will be guys, answer, it is sunflower. Okay, sunflower is used to detect the permanent wilting point. Yes, D is the correct option, Rakshita. Okay. Now, the law of maximum, which is used for developing the concepts of nutrient availability, was proposed by Wallace. Wallace has the law of maximum. Liebig, on the other hand, has the law of minimum. And Mitscherlich, he was another scientist. He gave the law of physiological return and growth law. Okay. And Ball was another scientist who gave the Ball percentage of nutrients. So, these are some things you have to remember. Bossingholt was another one who gave the field plot technique, and then there is Hilgard. Now, so this is law of maximum proposed by Wallace, which states that when the need is fully satisfied for every factor required in the process, the rate of process can be at its maximum potential. He stated that suppose there is a particular kind of process going on, and in every constituent of that process, it is at an optimal or maximum rate. So, that will be even greater than the maximum rate, because it is a cumulative effect of all that factors together. So, you have to add all that factors together, and that will pose a greater effect than the overall maxima that can be achieved. So, it is the sum of individual parts because of the sequentially additive interaction. So, there will be some synergistic reactions or additive reactions between the different particles, and that will further increase the process beyond the maximum capacity of that process. So, this is called as the law of maximum. Now, the concentration of different nutrients in ammonium phosphate sulfate. Tell me, concentration of different nutrients in ammonium phosphate sulfate. Okay, let's see. So, the option is option number D, that is 20-20-15. So, here it is a chart given of different fertilizers as well as their nutrient doses, and ammonium phosphate sulfate is over here. Okay, so either it can be 16-20-15, because here there is no 16 in the option, we are considering 20-20-15. 15% sulfur is present. Okay. Now, the assumptions of Darcy's law. So, Darcy's law is related to water flow. What are the assumptions? Kinetic energy of water is negligible. Okay. Mass density is not constant. Viscosity is constant and the flow is streamlined. Okay. So, what will be the answer, guys? Option number D, only B is not correct. Yes, because mass density is supposed to be constant. Flow is streamlined means the Reynolds number must be less than 1 for soil and must be less than 2200 for a narrow tube. Viscosity of water is constant, because and then mass density should also be constant, so that you can have a particular flux of water, and if this Q is not constant or if this Q is variable, then Darcy's law is not applicable. Okay. So, D is correct. Now, CEC of Montmorillonite clay. Now, often people get confused between Montmorillonite and vermiculite. Okay. So, Montmorillonite, yes, option number D or C, which one? I told you now, people often get confused. So, yes, option number C is the correct answer, because vermiculite has the highest CEC among the different minerals, and for vermiculite it will be 80 to 150. Whereas Montmorillonite, it has the highest external as well as internal surface area, so it will be 80 to 100. For the elite, it is 15 to 40. This is for kaolinite, and mica is a mineral with 0 CEC, no CEC, 0. Okay, so these some things you have to remember. Now, which of the following statements is or are correct about ZPC? pH at which the net surface charge of soil collides is 0. Yes, obviously ZPC means 0 point charge. So, the pH at which the net surface charge is 0 is ZPC. Then the value of ZPC will depend on the acidic or basic strength. ZPC of hematite is 4.5. So tell me guys, okay, C, they are saying C, only C is incorrect. So what is the ZPC of hematite? The ZPC of hematite on the other hand is from 6.5 to 8. Okay. Otherwise, all the above statements are correct regarding ZPC. Now, which group is RCH double bond O? So, everybody knows it is aldehyde group. It is aldehyde group. Everybody knows that. So, this was, I think that it was a PYQ in 2024. It was a PYQ in 2024, I guess. And very interestingly, I did this question wrong in 2024. This RCO, this one is ketone group and this is aldehyde group. Okay. And alcohol is OH and carboxylic is COOH. Okay. Yes. Let's go. So, father of organic farming, he is Albert Howard. Albert Howard is the father of organic farming, and Albert Howard also gave another thing. He gave composting, process of composting. Whereas Masanobu Fukuoka, he is actually the father of natural farming. Okay. He is the natural farming father and he is the organic farming father. So, yes, see, natural, and father of biodynamic farming is Rudolf Steiner. Okay. Now, which of the following is not a principle of organic farming? Health, care, fairness, equity. Which of the following? So, there are 3 principles of organic farming, and among that, health, care, fairness, see, ecology is there, okay, but equity is not there. So, instead of equity, it should be ecology. Basically, in some books it is written 3, in some books it is written 4, but the principle of equity is not there, it should be ecology. How many years the land or soil must be treated as organic without using any prohibited chemicals and other substances to qualify for an organic certification? For how many years your land must be treated to qualify for an organic certification? Guys, answer. So, it should be treated for at least 3 years. Okay. For perennial crops, it should be treated for at least 3 years. But in the interconversion period, what is the conversion period? It is the period from where your land should be converted into the organic one. So, this conversion period varies. It can be either 1 year if you are dealing with livestock. It can be either 2 years if you are dealing with the horticultural crops, okay, or annuals, and it can be 3 years if you are dealing with the perennials. So, option C is the correct answer. The capacity of a soil to produce crops with specific systems of management that is expressed in terms of yield is called as. So, whenever you are expressing it in terms of yield, it will become productivity. Okay. Fertility is the supplying capacity, but you do not express it in terms of yield. You express productivity in terms of yield, right? So, first see, you have fertility, then you have productivity, then you have soil quality, then you have soil health. So, in this way, the spectrum is first will come fertility, then productivity, then quality, and then health. Just a second. Now, so it is the capacity of a soil to produce crops with specific system of management. And what is the definition of soil health? It is the continued capacity of the soil to function as a vital living ecosystem, right? You have to memorize the definition that was given by Carlin. Fertility, yes, inherent capacity, whereas soil quality is just the capacity of a soil. The continued capacity is the health, whereas quality is just the capacity of the soil. Now, the acidity which is developed due to hydrogen and aluminium adsorbed on the soil colloid. So, here they are saying that these are the soil colloids and here we have H plus and Al3 plus, all that. So, this is nothing but exchangeable acidity. If it were present in the soil solution, then it were active acidity, and the residual acidity is the non-exchangeable acidity. Non-exchangeable acidity. This potential acidity is the sum total of exchangeable as well as non-exchangeable acidity. Okay. So, these are all the different pools of acidity that you must go through. The characteristics of sodic soil are, sodic means Na plus content will be high. High content of sodium should be there. So, if the sodium content is high, then what will happen? Exchangeable sodium percentage, it has to be greater than 15. So, in both the cases it is greater than 15. So, what will be the answer, guys, for the sodic soil? B is the correct option. The EC or the electrical conductivity is less than 4 because there is not that high percentage of salts. Whereas the pH, it should be always greater than 8.5. Okay. So, these are the different characteristics. Now, an element that plays a role in the plant metabolism, whether or not their role is specific or indispensable, it is called functional or metabolic nutrient. Okay, functional or metabolic nutrient, and this term was given by Nicholas in 1963. Functional or metabolic nutrient. What are beneficial elements? Beneficial elements will play an important role in plant, okay, like that of silicon and aluminium and sodium. Trace elements are found in minute quantities in plant. For example, you can have the trace elements are actually called as your second, this iron may be there, nickel may be there. Then heavy metals are that of lead, arsenic, cadmium. And then there are another elements called tracer elements that are radioactive in nature. Okay. So, this functional or metabolic term was given by Nicholas. Who is saying A? Okay. It is D. Okay. It is D. Now, which of the following pair is not correct? It is saying not correct. Sulfur was given by Saxon Cope. C. Nitrogen given by Saussure. Theodore de Saussure, right? P, K, C, A, M, G, all were given by Sprengel. S was given by Saxon Cope. Okay. But nickel was not given by Arnold and Stout. Molybdenum was given by Arnold and Stout. Right? So, only 4 is incorrect. So, you have to remember who gave all these different essential elements. Okay. It was given by Brown, Welch and Carey. Now, bitter pit in apple, tip hooking in cauliflower and cavity spot in carrot. These are the deficiency symptoms of calcium. Whenever there is bitter pit, this is a typical deficiency symptom of calcium. Okay. Whereas in case of copper, you will find that there are different deficiency symptoms of copper. As boron is lignification is there, gummy peels or gummy deposits. Okay. Then in case of nitrogen also. So, these typical deficiency symptoms of each and every element you have to remember. So, bitter pit in apple, tip hooking in cauliflower and cavity spot is there. So, this is our course and you can access it because JRF is strictly knocking at the door. So, all this has been covered in the master course. So, for the viewers who have not yet taken, please join in. Mottled yellow-green leaves with yellowish veins. See, first appearing on younger leaves are the deficiency symptoms of which element? Typically occurring in younger leaves. So, first eliminate magnesium because it will occur in older leaves. But it is saying mottled yellow-green leaves with yellowish veins. So, The chlorosis is intervenal chlorosis, right? So also eliminate the sulfur. Crop plants having nitrogen is to S ratio. So this is intervenal chlorosis because it is yellowish veins is there, yellow green veins are there. So it is sulfur. In case of iron, we will have intervenal chlorosis as well. But see, here they have motile function. And if it is complete intervenal, then there is manganese. Just a second. If it is complete intervenal, then we have manganese as the deficiency symptom, but the answer here is sulfur because obviously sulfur is immobile. So it will show the deficiency symptoms in new or younger leaves. Okay. Now, increase in yield of a crop as a result of increasing a single growth factor. So I mentioned just now that Mitchell, he has two laws. One is growth law and the other is a law of physiological relationship. So this is Mitchell-Leach growth law. Okay, law of maxima given by Wallace, law of minima by Liebig, and then there is Spillman equation. So this is Mitchell-Leach growth law. Here the definition is there. Just take a screenshot or whatever and read it. Read the slide. Okay. Now, when the concentration of an essential element in plant is sufficiently high to result in a corresponding shortage of other element. So, we have different terms. Deficient means it will produce some deficiency symptoms. Insufficient means where it is related to hidden hunger, where the symptoms will not be there. Okay, but still maximum growth will not be there. Toxic is when it will create a corresponding shortage, but excessive is when no symptoms are found, but still it is found in higher conditions. So, yes, option B is the correct answer, Rakshita. Okay. Depending upon the availability, the nutrient content in a plant could be deficient, sufficient. So, see, it should be option number B because whenever it is creating a corresponding shortage, then it is toxic. But whenever it is present in your plant, but it is not exhibiting any kind of symptoms, then it is excessive. Now, orientation of leaves and other parts of the plants towards sunlight is called. So, it is called phototropism. So, whenever there is orientation, it is phototropism. Photoperiodism is related to flowering and critical day length. Flowering and critical day length. And among that, you will have long day plants and short day plants. So, long day plants will at least need 12 to 14 hours of greater than that day length, and the short day plants less than 14 or 12 hours, okay, of day length. So, and then there are also day neutral plants like tomato. They will be not dependent on the diurnal length of the day. So, phototropism, yes, it is the correct answer. Next, most predominant mechanism of gaseous exchange in soil. Tell me. So, it is obviously diffusion. Okay. Mass flow is not there. Mass flow is related to the total pressure gradient, whereas diffusion is related to the partial pressure gradient. And all the contact exchange and ion exchange, these are related to the nutrient exchange movements. So, do not mess it up because gaseous exchange, if it is there, then diffusion will be the predominant mechanism. But if nutrient exchange is there, then mass flow will be the predominant mechanism. Okay, mass flow, because here the nutrients will flow along with water, and this is the most dominant mechanism for nutrient transportation. So, diffusion is the correct answer. Which of the following statements is or are not correct? Oxidation of ammonia to nitrite, okay. First step nitrite, oh, so this will be related to nitrification. Oxidation of ammonium to nitrite, okay. First step nitrite is carried out by Nitrosomonas nitrospira. Soil aeration is not much of an important factor. It is much of an important factor. Optimum temperature is 25 to 40 degrees centigrade. So, let us see what is the correct answer. It is option number D. That means only C is not correct, rest all the other options are correct. So, in case of nitrification, what happens? You have ammonia, from there it is converted into nitrite and finally it is converted into nitrate, right? And the first process is aided by bacteria like that of Nitrosomonas and the second process is aided by Nitrobacter or Nitrocystis. Okay. Nitrobacter or Nitrocystis, the second process is aided by that. So, option number D, only C is not correct. Now, urea formaldehyde contains how much percentage of urea? So, urea formaldehyde, it is a special kind of fertilizer which has been formed by combining urea with the formaldehyde. So, tell me what will be the answer? It is approximately 30%, 38%, sorry, 38, and in several books it is written 38 to 42% also you will find in several books. So, it is 38 to 42%, but within that 38%, over 30 is sparingly soluble and decomposes slowly, and because it decomposes slowly, the nitrogen availability to the plants is extended. So, it is a slow release nitrogenous fertilizer. Okay. Now, the potassium pools in the soil are solution, exchangeable, fixed or non-exchangeable and K in the lattice. So, all the different pools are of that of potassium only. This K in the lattice, it is in the primary minerals. Okay, primary minerals. This fixed or non-exchangeable, it is in the secondary minerals. This is exchangeable portion and that is soil solution portion. And the interconversion of this one, the reverse arrow is not present. Okay, only the conversion will be like this, single arrow. But for this one, the reverse arrow is present and it is very slow. But this one, it is very rapid. So, it is the dynamics of potassium exchange in the soil. So, all the 4 different kinds of pools of potassium are present. Now, wulfenite, perlite, ilmenite, these are the minerals of. So, all these are the minerals of molybdenum. Okay, all these are the minerals of molybdenum. So, let us see, wulfenite, perlite and ilmenite are the minerals of molybdenum. Similarly, the minerals of boron, you will have tourmaline. Tourmaline as an important mineral of boron and that too in alkaline soils, right. Then for the zinc, you have sphalerite, smithsonite, franklinite, okay. This iron we have siderite, then hematite, magnetite, goethite. So, you know this, all this, okay. Now, the conversion of organic form into inorganic form. So, organic is getting converted to inorganic, that means availability of a particular nutrient is increasing. So, it is mineralization. If it were the reverse, then it is immobilization, okay. Then humification is the process of formation of humus and fertilization is the process of applying fertilizers to different soils. So, yes, option number A will be the correct answer. That is the conversion of organic into inorganic forms. So, this is the end of the 60 question session. The rest 60 questions will be handled on a later on session. So, if you had got any benefit out of this session, please give a thumbs up. And if you have any doubts regarding that, you can always comment in the chat box. And if this session was helpful to you, then I would urge each and every one of you to also attend. Okay, thank you, Karthik. So, you have to also attend the other sessions, okay. So, that's it. Okay. Goodbye.